now. So, hi everyone, I'm Tejas. I didn't introduce myself during the lunch earlier, but they just did that for me. Thanks for inviting me to the ISI seminar. I've been wanting to visit ISI for the last 4 years of my PhD and have failed to do that. So it's nice to finally have an excuse to visit. And yeah, today I'll be talking about my work on improving human AI collaboration by adapting to user trust. So this might be a little different from previous seminars because there's not a whole lot of language models, NLP going on here. This talk is going to be more on like human AI interaction, but hopefully you'll still find it interesting. Also, if we could keep, if you have like questions that are like clarification questions, you can interrupt me and ask those. If you have questions that are more like higher level questions that could like kind of derail the talk, let's save those for the end. All right, cool. Okay, so AI systems are increasingly being used to assist decision makers in a wide variety of fields, from healthcare to education to defense and even economic policy. However, as you and I are well aware, AI assistants aren't always reliable. Headlines like these have become far too common, where an unreliable AI system causes some harmful downstream outcomes. Harmful not just for the people who are deploying the system, but also for people whose lives are affected by the consequences of these decisions. So how can we make AI assistants more reliable? If I ask an AI assistant, like, okay, like these are the symptoms I'm feeling feverish, tired, I have a mild headache. What do you think I have? And the AI assistant comes back with me, comes back to me saying, oh, I think you have the flu. How should I, as a user, know whether the assistant's response is reliable or not? To this end, the research community has developed numerous tools for improving the reliability of AI systems. These include getting lower bounds or guarantees of model accuracy. The best way, of course, to improve the reliability of AI systems is just to make them more accurate. But aside from those, tools include lower bounds and guarantees on model accuracy, identifying the model's knowledge boundaries. So being able to detect when input instances are out of distribution and not in the model's training data, and hence the model should probably abstain from answering. Estimating model uncertainty and calibrating them so that they're indicative of like real ground truth correctness. Getting model explanations that are hopefully faithful to the model's actual internal reasoning, and a lot more, including like citing sources and like RAG and stuff. So this is how we in the AI community think about reliability. Like these are the tools that we have come up with to make AI assistants more reliable. But how do we go from having AI assistants that are reliable to having user AI collaboration that is reliable? So this means when a user wants to collaborate with an AI assistant for some task or use the AI assistant to inform their decision making, how can they know that they will collaboratively come to a reliably accurate outcome? So what does reliable user AI collaboration actually need? So reliable user AI collaboration needs joint goal understanding between the user and the AI system, building common ground between the two interlocutors, balancing user expertise with the AI expertise, and calibrating user trust to the AI assistant's actual trustworthiness. Now, if you notice, there's a bit of a gap here between what we in the AI community think of on the left side and what is actually needed for user AI collaboration on the right side. And bridging this gap requires considering human factors that play a crucial role in deciding how users decide to rely on AI assistants when interacting with them. So this requires considering human factors that are not typically built into these reliability tools that we develop. So what kind of human factors affect human AI collaboration? So in today's talk, so human AI collaboration can span like a vast range of control levels between the user and the AI, where the user completely gives away control to the AI and lets the AI do all the decision making for them, or the user has like manual oversight, or the user or the AI system, the user is only involved when the AI system is uncertain and wants to defer. So there's various levels of like user like control, and also different types of like collaboration tasks. Like for example, something like answering questions or diagnosing patients is going to be different from collaborating on a writing task together. But for the purpose of this talk, we'll be looking at just AI-assisted decision-making. So this is a setting where the user has like some decision-making tasks that they're trying to make a decision for. They ask the AI assistant for a recommendation, which the AI provides, and then the user makes the final call for whether to accept or reject the AI recommendation. So in this kind of AI-assisted decision-making setting, there's this goal that human AI researchers have come up with, which is called appropriate reliance, which is an ideal scenario where the user always accepts AI advice that is accurate and always rejects AI advice that is inaccurate. So if you think about the user as a kind of classification model for whether the AI is giving correct advice or not, this is basically that the user has perfect precision, perfect recall, perfect F1, right? And ideally, this is what we always want to see, like that users know when to trust the AI, when to rely on the AI advice and when to not rely on the AI advice. And this is especially important for downstream tasks that have like high stakes. For example, something like diagnosing patients based on symptoms, where having an AI assistant give a recommendation can improve the user's accuracy, but the user needs to know when to trust whatever the AI is recommending and when to go with their own intuition. So in these kind of decision-making settings, what factors affect a user's decision to rely on AI assistance or not to rely? And this is a question that the HCI community has investigated for several years. And they've identified several factors, such as the user's self-confidence. So this is how confident the user is in themselves versus the AI's capabilities. The user's perceptions of the AI's accuracy, which develops over time. How uncertainty is expressed by the AI assistant, whether uncertainty is expressed through like numeric confidence scores or linguistic hedges, or through like visual devices. Or even their prior experience with AI systems. So as AI researchers, we tend to have a, well, I won't say better prior, but maybe a different prior about AI system capabilities than a layperson. So a lot of work in HCI has investigated these like different factors, but what has been less studied is user reliance on AI assistance over longer timescales spanning multiple user AI interactions. So whereas previous works would just look at, okay, if I give a doctor a diagnosis task and give them an AI recommendation, will they accept the AI advice or not? But instead, can we see like basically over multiple diagnosis problems, how does the user's reliance behavior on the AI recommendation change over time? So this has been like relatively less studied. And there's one important factor here that that you see in like these longer timescale interactions, which is trust. So trust is defined as a user's belief that in the context of a user AI interaction, trust is defined as the user's belief that the AI assistant will help them achieve their goals. So it's important to keep this definition in mind. And it's important to know that this is a mental state of the user that can be reflected in like their downstream behavior. There's a lot of like inconsistency in the literature, I would say, about how the word trust is used. Sometimes people see like, people look at if the user relied on an AI advice and be like, oh, like that is trust, like the user is trusting the AI system now. Whereas some other work looks at, like draws the distinction of like, oh, trust is like purely a mental state and the observable downstream behavior is reliance. And I'm personally going to go with the latter distinction. I think it's like a bit of a cleaner distinction between trust and reliance. So yeah, so that distinction is kind of important to keep in mind for this talk. So the reason trust is so interesting in this longer timescale setting is that user trust in AI systems evolves as they interact with the AI. So for example, in this setting, in this example where a doctor is coming up with diagnoses based on like AI assistance, based on AI advice, if they can observe downstream that the AI is giving like correct recommendations here, their trust in the AI is more likely to increase over time. But then after the AI gives like a couple of incorrect recommendations, their trust is likely to fall again. And because all people are different, there's no like standard way that this trust necessarily evolves. Sometimes, like even if the AI gives you something that's misleading, but you are also incorrect, maybe your trust doesn't follow anymore, but for some other person it might. But yeah, basically, people have shown that these like trust levels evolve as users interact over longer timescales. And the reason that this like mental state is actually important is because it impacts how users engage with the AI system in future interactions. So at this point, if after like this fourth task where the user's trust is now very low, if the AI gives a recommendation the next time, the user is much more likely to disregard the AI recommendation because they trust the AI advice less. And this is likely to, so this situation is likely to lead to under-reliance, where the user incorrectly rejects accurate AI advice. And the opposite case, where the user, let's say, has very high trust, is likely to lead to a case of over-reliance, where the user accepts AI advice too willingly and may end up making mistakes as a result. So that brings me to the two research questions I'll tackle in this work. First, does user trust act as a cognitive bias for users' decisions to rely on AI outputs? So this first research question is kind of a sanity check of like intuitively we would think that like, oh, like yes, as people trust something less, they're like less likely to rely on their advice. But this first research question is run as a kind of sanity check. And also to like see if this finding holds in our decision-making task setup here. So we hypothesize that when user trust is very low or very high, users do not consider AI recommendations as carefully. And this is likely to result in negative outcomes at these like extreme levels of user trust. And the second research question, which is the one that hasn't been studied before, is can adapting AI behavior in response to low or high user trust improve users' decision-making? So basically, can we offset the effect of this cognitive bias and elicit more careful consideration of AI recommendations by users by adapting AI assistant behavior strategically during moments of low or high trust? Yes.
For the question one, is trust a fine-grained enough metric? I mean, there could be trust in certain tasks specifically. I'm wondering if you tackle that.
Yeah, in our user studies, we only look at like a single task with like multiple problems over time. So the trust is like kind of grounded in that task itself. And there's also like different ways that trust could be like operationalized. One paper I've seen has like people basically like bet on the AI's correctness. In our work, I'll come to what we do in our work. Yeah. But yeah, it's not necessarily a fine-grained, or like it could be more fine-grained depending on the spectrum of tasks that the user is like interacting for. Yeah. All right. So I'll start off by describing the setup of our AI-assisted decision-making task. So this is basically the setup for our user studies. This paper mostly just has user studies and not much else. So I'll describe the setup for this. So each user who's participating in our user study is tasked with 30 decision-making problems that they do in a sequential manner, one after another. So on the left side, we see that like, okay, the user has already interacted for some number of time steps and their trust has developed to some level as a result. In each decision-making problem proceeds in 3 phases. In the first phase, which is the independent decision-making, here the decision-making problem is presented to the user, and the user makes a prediction about what they think the correct decision should be. So in this case, in the task with like where the doctors are doing like medical diagnoses, they're presented patient symptoms and they are presented some possible diseases, diseases, and they have to pick which one they think is like the right diagnosis. In the second stage, which is the AI-informed decision revision, the AI assistant provides a prediction of its own along with a confidence score. So the reason that we present confidence scores is that HCI, like research in HCI has found uncertainty estimates to be a much more, a much better reliability tool for users than, let's say, something like explanations. And after receiving the AI recommendation, the user now has the option to like update their prediction, either to whatever the AI said or whatever they had like initially predicted, or they could even do like something different completely out of the like other options that are available. And finally, we show them what the correct diagnosis or like what the correct decision is. So for example, the correct diagnosis here. And then we ask them how much they trust the AI system to help them with the task based on all their interactions so far. And the user reports their trust score on a scale of 0 to 10. Yeah.
This is so over the decision-making processes, it's assumed that the confidence in the AI is reflective of their entire experience.
Their trust in the AI is reflective of.
No, they're not meant to be independent. They're meant to be.
Yeah. So you can treat it as a Markovian thing where the trust at the reportedly like last time step, it kind of encapsulates all the information of from trust before, or like all the interactions before.
Experimental setup question: are the queries to language models fixed for each trial, or is it the user that's actually querying and getting responses and getting confidence?
The decisions.
Yeah.
Oh, sorry. The problems.
Yeah.
The problems are fixed by the choice of our data sets, and I'll get to those. The AI prediction and confidence, I'll get to that as well. And this proceeds for like 30 decision-making problems for each user. And basically we can study, actually, I'll get to that. Yeah. So this is like the basic decision-making setup in our user studies. Some more details. So we looked at 2 decision-making tasks. One was answering science questions from the ARC dataset. This is a dataset released by AI2, not the like AGI benchmark thing that we talk about now. But these are like science-based questions, like this one over here. And the other task is a diagnosis task from a dataset called DDX+. So this dataset has, the questions have like demographic information about the patient and the symptoms that they're presenting. These are like symptoms that are typically submitted at like intake forms, on intake forms. And for the ARC task, we have like 2 possible answers that may be correct. Well, one of them is correct. And in the diagnosis task, there's like 4 possible conditions that the patient may have. So for the participants themselves, for the ARC task, we use laypeople as our participants. So we conducted all the user studies on the Prolific platform. So I guess we bias for people who are likely to be on these kind of platforms. And we have like, I think they need to have like graduated high school. But yeah, these are like lay people. And for the diagnosis task, we have doctors as our participants. So these are doctors who are also on the Prolific platform, of which there were more than I expected, and who were generous enough to take our study. Yeah, so these are people who actually have like domain knowledge for this diagnosis task. So they actually know how to like interpret these symptoms and not just make like random guesses. Yeah, so this is like a more realistic setting where a domain expert is using an AI assistant. The lay people achieve an accuracy of about 67% on the ARC task without any AI assistance. And the doctors achieve like a 74% accuracy without AI assistance. So this accuracy without assistance is basically looking at the accuracy of the initial decisions that they made before the AI presented any advice. For the AI assistant, we use simulated AI assistants for most of this work, and I'll come to how they are simulated exactly. But we experiment with two kind of simulated AIs. One is a calibrated AI system, and one is an overconfident AI system. So with the calibrated AI system, the confidence score is reflective of like the actual likelihood of the AI being correct. And in the overconfident assistant, the confidence score is usually higher than what the AI's actual correctness likelihood is. What we evaluate in our user study is the correctness of these final decisions that the user makes. And there's three key metrics that we look at here. So one is switch rate. So switch rate is basically of all the interactions where the user's initial decision did not align with what the AI recommended. How often did the user switch to what the AI recommended in their final decision? So both of these cases are cases, sorry, the case on the left is one of a switch where the user switched from, sorry, no, the one in the case is a case of the user not switching because they stuck with option 2. And the case on the right is the one of the user switching from option 1 to option 2 based on the AI recommendation. So switch rate is basically just seeing like how often does the user switch, but this doesn't tell us about like whether the user made the correct decision by switching or not. So that's why we use these two other metrics, under-reliance and over-reliance. So under-reliance captures basically of all the cases where the user and the AI disagreed and the AI was the correct one, how often did the user stick with their original incorrect decision? So this is like a false negative rate, basically. So the case on the left is one of under-reliance because the AI's answer of option 1 was correct, but the user stuck with option 2. Over-reliance is the opposite. How often, out of the cases where the AI was incorrect, how often did the AI switch over from their own decision to what the AI said? And that's the case on the right, because here the AI was incorrect and misdiagnosed the person and the patient, and the doctor switched over to what the AI said. So these are the metrics that we will look at and keep talking about throughout this work. For how we actually simulated these AI assistants, this is kind of simple. Instead of having like a model generate predictions and confidence scores, instead we first sample the confidence score from this uniform distribution between like 0.5 and 0.95. And then based on this confidence score, we decide if the AI prediction, which is like this variable on the left here, is going to be the ground truth or one of the incorrect options. So because of the way we're sampling the AI predictions, it's bound to be calibrated, basically. For the overconfident AI, we first sample the confidence score as before, and then we sample a like true confidence from this like triangular distribution. And then based on this like true confidence, we sample if the AI's answer is, if the AI prediction is going to be the correct answer or an incorrect option. So again, because the true confidence is lower than the confidence that we sampled here, the likelihood that the AI is correct is going to be lower than the confidence that's shown to the user. So therefore, this is bound to be overconfident. And looking at the calibration curves for the predictions that we generated, we see that the calibrated AI assistants for the ARC and diagnosis task, which are the green curves, they have like pretty low calibration errors, like 0.02, 0.04. Okay, actually, let me explain what a calibration curve is. So calibration curve basically captures how good a model's confidence confidence estimates are over a set of predictions. So basically, so on the x-axis, you have like the average confidences that are shown to the user, and you bucket the samples by the confidence, and then see, okay, for all the AI predictions that were, let's say, 60%, what was the actual accuracy, and was that accuracy close to 60 or not? If it was exactly 60, then that's what we consider to be perfectly calibrated. If it's higher than 60, then it's underconfident because the confidence is less than the true accuracy, and vice versa. So for example, for the orange one here, if you look at the middle dot, for samples where the AI confidence was between 70 and 80%, so like on average 75%, the actual accuracy of the AI predictions was about 65%. So it's an overconfident model, yes.
So is the reason your green line isn't on the main diagonal just because of a low sample size?
Yeah, lower sample size. All right. So the first research question was, does user trust impact reliance? So now we'll be considering the user trust at the start of an interaction. So we want to examine the relationship between the user's self-reported trust level on a scale of 0 to 10 after the ith interaction, and then user reliance metrics for evaluating the I+1 interaction. And our prediction is that, let's say if the user has very low trust, they're much more likely to disregard the AI, so much more likely to have like lower switch rate. And also this will lead to under-reliance. So the under-reliance metric, which is typically where typically lower is better, we're likely to see like higher under-reliance, so higher percentage of accurate AI predictions are being ignored. So the way we do this is for each task, we collected interaction data from n subjects. So this was like n equal to 30 for the ARC task and 20 for the diagnosis task because there were doctors. And then we aggregated the n times 30 interactions. So we have like 600 interactions that we looked at for the doctors and 900 for the ARC task. We filtered out interactions where the user's initial prediction matches the AI answer. So in those cases, the user, like 99% of the time, just sticks to their own prediction. There's nothing interesting to actually see there. What's interesting is when the user's initial prediction disagrees with the AI prediction. So we filtered out the interactions where the user's initial prediction agrees with the AI. And then we bucketed interactions by users' starting trust level. So this is the trust level that they reported in the previous interaction. And then looked at our various reliance metrics.
Couldn't the agreement actually help build trust though? Like, for example, if doctor knows the answer to this diagnosis and sees the model is very confident in the right answer, doesn't that build trust? So
it will build trust. And then we do ask them to like report their trust, even for those interactions as well. Mm-hmm. But that trust will then affect the nature of like the next interaction. Yeah, so you are right. And we do use that trust data.
Okay.
All right, so findings for RK1. So we actually have like 3 settings. We have like the ARC task with the calibrated AI, ARC task with the overconfident AI, diagnosis task with the calibrated AI. We didn't do diagnosis and overconfident because not enough doctors. On prolific, not like in the world, also probably in the world, but on prolific specifically. Looking at the relationship between user trust on the x-axis and switch rate on the y-axis, we see a very strong positive correlation. So as users' trust increases, they're more likely to accept AI advice. This is like pretty intuitive. I guess I don't need to go very deep into this. Now looking at the other reliance metrics, so over-reliance. We again see that there's a moderate to strong correlation between user trust and over-reliance. And especially like at very high levels of user trust, the over-reliance increases quite a lot, which means that users are making worse decisions by accepting AI recommendations, by accepting incorrect AI recommendations too readily when their trust is too high. Similarly, we also observe worse under-reliance at lower trust levels. So we find that under-reliance is strongly negatively correlated with user trust. And yeah, let's say trust less than 5, I think the under-reliance score is like generally much worse for users. So here, when users have like very low trust in the AI, they're much more likely to disregard what the AI is saying. So the takeaway is that users make worse decisions when their trust level is too high or too low. Now this like matches our intuitions, or at least the intuitions I had in this project. And we ran this experiment as like a sanity check to make sure, like what we expect holds in our decision-making setup. But then this allowed us to like identify the problem and move on to the actual interesting research question, which is, can AI assistants mitigate under or over reliance by adapting their behavior in response to trust levels? So in the previous experiment, we observed that at extreme levels of user trust, users consider AI recommendations less carefully. Can adapting AI assistants in some way during these moments promote more thoughtful deliberation from users? So let's say we have this diagnosis task again, and we have a doctor who's currently not very trusting of the AI at all. And as you can see, she's very angry over here. So at this point, when the user trust is low, is there some intervention that we can introduce to have the user consider the AI recommendation more carefully? And the main intervention that we explored is using natural language explanations to support the AI prediction. So a lot of work in HCI has found that explanations tend to cause over-reliance by users, because just like the presence of an explanation, regardless of like whether it's faithful or not, just the appearance that the model knows what it's talking about is enough to convince people that the AI is correct, and people tend to like readily accept the AI recommendation when it comes with an explanation. Even well, I won't speak for you guys, but when I use ChatGPT and it comes out with like long explanations with a bunch of like emojis and section headings and subsections, my eyes tend to glaze, and I just like scroll through it, get to the bottom of like, and see what it's saying, and just like, oh yeah, like that sounds correct. It sounds like it went through a reasonable process, and I don't like closely like scrutinize the explanation, let's say, to see if it matches my intuitions. Yeah.
Do you think that even just the comfort of scrolling through makes you more likely to accept the answer?
Like you reach like a more Zen state?
No, I'm saying like if there was no explanation, do you think you'd be less trustworthy?
So trustworthy, I would say,
Sorry,
is
do
a
you think
bit.
you would trust them less?
Yeah. I think, yeah, like that's basically what is happening here. That just like seeing that the AI,
There's an explanation.
that there is like a plausible sounding explanation for the model. I mean, we have like a bias for plausibility. I think that itself is enough to like convince users that, that they're talking about. Like, even like I'm explaining my research to you, but I don't know if you're scrutinizing my talk that much. I might just be BSing this whole thing. But anyway, so we hypothesize that at these moments when trust is low is when users are likely to be more critical of the AI and actually scrutinize these explanations more closely. So we propose providing these supporting explanations in natural language form that explain why the AI's prediction is what it is. Similarly, during moments of high trust like this, we hypothesize that providing counter explanations for why the AI prediction may be incorrect might be useful to stop the user from like readily accepting the AI recommendation without thinking too much themselves. So here, for the exact same prediction, we also have a natural language explanation where it's like, oh, the AI prediction might actually be incorrect because like, oh, this symptom doesn't exactly occur with pneumonia very often, Yeah, so for most of this talk, I'll be talking about the natural language explanation interventions. So yeah, first we try to mitigate under-reliance with supporting explanations. So the strategy here is when the user when the user has reported in the previous interaction that their trust in the AI is between 0 and 4, in the next interaction, we will also provide a free text explanation to the user. We generated the explanations using GPT-4. Yeah, that's the extent of LLMs. Actually, no, that's not true. But in the initial submission, this was the extent of LLMs in this paper. Yeah, and we examined 3 conditions. So one is the no intervention condition. Oh, yeah, there's 3 conditions. One is the no intervention condition where when the user trust is low, the AI doesn't change its behavior at all. The other baseline is the supporting explanation always shown. So this is where the supporting explanation is shown regardless of like whether the user has low trust or high trust. And our trust adaptive intervention is the one where the supporting explanation is shown only when the user trust is under 5. Yeah. Something.
I can ask at the end. This one.
Previously?
I can ask at the end.
Oh, okay, cool. Okay, so in this graph, we'll look at the under-reliance metrics and the accuracy of the user's final decisions. So under-reliance, lower is better because we don't want users to reject incorrect AI prediction, AI advice, and we want users to make more accurate decisions. So we see that across all settings, the calibrated AI results in, sorry, not calibrated, the trust adaptive supporting explanation results in lower under-reliance and higher decision accuracy. Most of these were like statistically significant. I think the 3 stars are like under 0.001 and 2 stars are under 0.01.
Wait.
The p-values.
You're not showing over-reliance, so. You're just showing under-reliance and.
Yeah, so in this case, in this setting, we're only trying to mitigate under-reliance. We want to see that like at moments of low trust when users are likely to like not accept AI advice can we mitigate under-reliance? But we do have an additional metric here where like while reducing under-reliance, we don't want to like increase over-reliance to the same extent, right? So we have another metric called total inappropriate reliance, which is the sum of the under-reliance and over-reliance over those interactions. And we want to see that like that is also lower, you know, we're like at the expense of mitigating under-reliance, we're not accidentally increasing over-reliance. And in our paper where we have the full results, we do show that like total inappropriate reliance decreases as well. Yeah, and also we see that like these supporting explanations, like our improvements are not solely due to the supporting explanations, but also the trust adaptive component, because if we always provide supporting explanations regardless of trust, which is like the pale, like the lavender bar, the under-reliance doesn't decrease as much, and in some cases increases actually, results in worse decisions. So providing explanations adaptively reduces under-reliance and improves users' decision accuracy. Similarly, for mitigating over-reliance with counter explanations, so whenever the user has reported in the previous interaction that their trust is above an 8, the next AI recommendation will be accompanied by a few sentences about why the AI thinks it might be wrong. So here, again, we have like the no intervention condition, the always shown condition, and our trust adaptive condition. And here we look at mitigating or like reducing over-reliance and improving decision accuracy. And here we see that across all settings, again, the adaptive counter explanations reduce over-reliance, improve decision accuracy, and that this doesn't come at the expense of increasing under-reliance, like the total inappropriate reliance also stays under. Yes.
Can I see the previous slide?
Yeah.
Something that kind of surprises me is that the like always showing the supportive explanation is very like it's worse for the calibrated AI than for the overconfident AI. Do you guys have any thoughts? Because it seems that happened in this case, but not the over-reliance.
Yeah. This was like an outlier, but my suspicion is that this is partly due to a sample size problem. So with the calibrated AI, the user's trust actually doesn't get low very often. Yeah, so in the paper, we have like the number of samples in each of these bars as well, like annotated. I removed that for clarity. But basically the calibrated AI has like fewer samples. So that's also the reason that our improvements are not statistically significant in those cases. Because we just have like more like I think if we collected more more studies or like more participants with the calibrated AI, we would eventually get to like the right number of interactions. But
You have a Monty Hall problem, right?
it's kind of like a Monty Hall.
What I mean is that there's wait, so you're always showing the confidence, right?
Mhm.
And they know that there's a fixed number of choices. So like you could think of the low confidence, like if you have a low confidence, especially in the 4-choice case,
Mhm.
if they're catching on to what's going on, when you have a low confidence, there's like a very big chance that like, you know, this is an answer that should be eliminated kind of case, right? Like that in fact, the model's prediction should be considered as almost certainly wrong. So it does provide information, even if it's a bad advice.
It does.
Let's consider choice where you choose A, and then with very low confidence, it shows you B, right? And now your choice is, should you stick with A or should you switch to B, C, or D? You're very unlikely to switch to B in this case, but in fact, but if you hadn't seen that, you might have like a reasonable, you know, more likely to switching to B, C, or D. Now you might switch to C or D.
Sure, but also like your initial prediction of A is also not
You know, the Monty
necessarily.
Hall conundrum, right? It's actually usually better to switch.
Yeah. Well,
In fact,
I think they have to like kind of think of us or the AI as like a game show host that kind of is like giving them misleading advice or like telling them what might
Well, and
be.
there's low confidence. It's most like, especially for the calibrated test.
So for low confidence, we do bound our confidence estimates to like 50 like it has to be like 50% plus.
Well, I guess what I'm saying is, so this calibrated AI choice, what you're saying is that, sorry, the high number means it is under-relying, which means it's going to say it's more likely to not choose what is provided.
What do you mean by it? Like the AI?
Sorry, the human decision, if they're under-relying, is to choose something other than what is predicted.
Yes. Or like stick with their own decision, basically.
Does it have to be that?
Well,
Or for
in the ARC task, yeah. In the diagnosis task, not
I
necessarily.
see, okay.
And most of the time, I would say, because the ARC task had like 2 options.
All right, maybe I haven't solved this.
We can talk about it more afterwards. So basically, summary from these last 2 slides that supporting explanations, like presenting supporting explanations when user trust is low helps mitigate under-reliance, and presenting counter explanations when trust is high mitigates over-reliance. And the next natural thing is to like put them together, you know, like show supporting explanations when trust is low and show counter explanations when trust is high, and see if that yields like complementary benefits, or if there's like some kind of interference between those interventions. And we see that for the most part, it does have like complementary performance improvements. So the pink one is the one where we kind of put both of them together. And we see that across all interactions, the decision-making accuracy improves when both kind of interventions are used. And the total inappropriate reliance, which is the sum of under and over reliance, is also lower.
Wait, why are blue, green, and pink in the trust in the 5 to 8 range any different from orange?
They should not be. So, I mean, the numbers might be different, but the behavior is not different.
So it's the pink represents a run when this setting was on,
Yeah,
but it's
yeah.
the case where the behavior is the same as the orange. So,
Yeah,
so
the
that kind of shows you the error.
Yeah, so the hatches kind of show you like when the interventions are actually happening. So in this trust less than 5 case, for the purple and the pink, the intervention is being applied, which is like a supporting explanation is being shown. But for the orange and green, nothing is going on, like nothing different is happening with the AI at this point. And similarly over here, when trust is above 8, for the green and pink, an intervention is being applied, which is a counter explanation is being showed. But for the orange and purple, there's no different behavior happening.
So this is like an inexact way of saying this is like about 13 points is the like non-statistically significant range. That's not true, but it's something like that.
30, oh, the 56.
56 to 69.
Depends also on the sample size.
I'm saying for these,
Huh?
for these experiments.
Yeah, for this experiment, I couldn't run an exact statistical analysis for some reasons. I think for this metric, it doesn't actually make sense for the inappropriate reliance. For accuracy, I could have checked. But yeah, I haven't run significance tests for this one, but maybe I should.
But you're in bound by my bad way of doing the analysis.
Sure.
It seems like your
Sure.
intervention is outside the range.
Yeah.
Which is good.
Yeah, and yeah, so the experiments that I showed you so far was like with a simulated AI. But now what happens if we actually apply this to a real AI assistant that is giving like live advice to a user? So here we have users interact with Llama 3.1 on the arc task again. So here we have like Llama basically, for each question, it generates like 10 different chain of thoughts plus predictions. The majority prediction is selected as like the LLM prediction. The relative frequency of the majority prediction is its confidence. So this is using like a self-consistency method for computing confidence. And we use the, like one of the chain of thoughts that correspond to the model prediction as like the model explanation, and one of the chain of thoughts that resulted in a different prediction as a counter explanation. So we ran these studies again, where users were interacting with Llama 3.1 instead of our controlled AI assistants. And again, we were seeing that decision accuracy was improving during moments of like low and high trust. Inappropriate reliance overall was decreasing during moments of low and high trust. Under-reliance was decreasing when trust was low. Over-reliance was decreasing when trust was high. So our findings were basically generalizing to a real LLM assistant. When we first submitted this paper, reviewer 2 got very mad that we didn't have this, not this experiment, but they were like, why the hell is this submitted to an NLP conference? So then we added this and they were like, okay, I don't like you anyway.
So that's how it goes.
It was the same reviewer, right?
Oh yeah.
So they have to accept it.
Oh no, I think the next time we switch reviewers and whatever. ARR is a shit show. Wait, you're not like on the ACL committee, right?
For some definition, I am, but
Too late.
I said ACL is a great show.
it's going on YouTube.
Yeah, so in the experiment so far, I've used supporting and counter explanations as our intervention method, but there's nothing inherent about explanations that, or there's nothing about like being trust adaptive that is inherent to this explanation intervention. So we ran another set of studies where we tried a different type of intervention or like adaptation of AI behavior. So here we basically decelerated and applied friction. Get it? Anyone? Friction to the interaction by slowing down the interaction and promoting reflection. So in this, what we did was whenever the user trust was low, we showed the user a message saying, oh, the AI is thinking ... For 10 seconds, they didn't have the option to like make a decision. They had to like wait to see, they had to wait 10 seconds to see the AI prediction. And then they had to like come to their final decision. When the user trust was high, we would show them the prediction, but then we wouldn't let them make a decision for 10 seconds. So for a 10-second timer, they couldn't see the buttons to like make the next decision, and they had to actually like think for themselves whether the AI was correct or not. And only after 10 seconds were they allowed to make a decision. So looking over here, so the purple is the AI is thinking when trust is low intervention, and the green is the adding a forced pause when trust is high intervention. We see that adding a forced pause, forcing users to pause when their trust is high helps quite a bit. We see like improved decision accuracy and lower inappropriate reliance during moments of high trust. But just saying that the AI's thinking is not enough to deceive the user into thinking that the AI is actually reliable.
Become more under-reliant.
Yeah, it might even become more under-reliant. Yeah. So, yeah, this is like another set of experiments showing that like trust adaptive interventions are useful, but you need to put some thought into what those interventions are exactly. So, one question that I'm sure some of you have been thinking is that one limitation of our setup is that we are forced to poll the user at the end of every interaction and ask them, oh, how much do you trust me? How much do you trust me? How much do you trust me? Which can be irritating. It would be much better if we could have a model of the user trust instead, based on the interactions so far, and based on whatever our predicted trust level of the user is, the AI decides to adapt its behavior or not. So we tried a few different trust estimators. So the first 4 of these, which are all like poorly named, are heuristics. So these are like the AI's accuracy over the last 5 interactions, the difference between the user's accuracy and the AI accuracy in all the interactions so far. And the smoothed ones are basically ones where there's like a smoothing parameter to give a higher weight to more recent interactions. And then we also trained a linear regression model that looks at certain interaction features like the user's initial prediction and their confidence, the AI's confidence level, was the AI correct or not, did the user end up making the right decision or not. We had a lot of these as, we had a bunch of these as features, and then use that to predict how much the trust will change in the next time step. And to train these, we use like some offline data. So we had some like additional, I think maybe 50 users data to train on. And we trained on a bunch of these and looked at the correlation between the predicted trust levels and the actual user self-reported trust scores. And we see that at best, we get like about 0.5 correlation between like the predicted trust levels and the actual trust levels, which is not great. Furthermore, when we looked at how good they are at detecting moments of low or high trust, the F1 scores were not very good at all. So it has like a F1 of under 0.5 at detecting moments of high trust. And I think the highest was like exactly 0.5 at detecting low trust. So yeah, basically we found that modeling user trust is a very challenging problem, and it's not very easy to do directly by looking at interaction level features or like surface features. Instead, you need like some more cognitive modeling, perhaps. All right, so takeaways. So first of all, trust is an important human factors that modulates how users decide to rely on AI assistance or not. And the reason it's important for us as AI developers to consider is that it can also allow us to design AI systems that are adaptive in response to these trust levels, and helps users make better decisions and mitigates their cognitive biases. Modeling user trust is important, but a hard problem. There's work in the cognitive science that has looked at building trust models that I haven't engaged with sufficiently, maybe. But I'm not going to say, I didn't say that in my thesis proposal, but I can be honest here. Oh no, this is going on YouTube. Okay, but anyway, modeling user trust is important, but challenging. So there's more work to do there. And there's several implications for designing NLP systems as well. And I was forced to think about these thanks to the reviewer too. It's like, what is this doing at ACL? So yeah, so there's a need for learning from and adapting to the user AI interaction history. I hope I've like conveyed that sufficiently. Another is that there's been a lot of discussion in the NLP community around the utility of natural language explanations to users, including work from Brihi from USC. And they found that like explanations aren't always useful. They often cause over-reliance. And our work suggests that user trust is actually a good cue for knowing when to provide explanations to users. And finally, I also think, so I think around the time I was doing my proposal, like test time scaling became like a big thing. And I think trust is also like an interesting cue to use to decide like when to do additional inference. When you have like a limited inference budget, deciding to do additional inference during moments of low trust when you might want to actually like improve the reliability of your system might lead to like better downstream outcomes. So thank you. Actually, did that.
I have a very serious criticism.
Oh, Sabi first. Go ahead.
Interventions or like my main question is that is the in experiments for the interventions are different from the experiments for the RQ1, or are all of them happening in the same study?
Oh no, I mean they have the same study setup, but I had to run them with different users. And, yeah. Like the user interface and everything was the same, like for the user study. But yeah, I had to like run more studies. I had to run too many studies. I kind of lost my mind on prolific.
So you have like your interventions. By interventions, I mean providing explanations or explanations of counterexamples. That depends entirely on the trust level of user trust. But I was thinking, I mean, especially for your calibrated models, confidence is also another important,
Yeah.
metric or decision about whether you want to provide counterexamples, right? So I'm wondering, like, if you triggered the explanations based on confidence, how would it compare to basing it on solely trust? Because like you showed, like there is pretty good correlation between accuracy and confidence. So yeah, just a thought, maybe an extension. I don't know. Yeah.
Well, I think that's an interesting idea, and like if the AI knows that it's going to give a calibrated response, which in our study, we had like, the reason we use simulated AI assistants was so that we could like control the calibration on our end. So if the AI assistant knows that it's going to be like a calibrated response, and when it says 100% confidence, it's going to be 100% correct, then maybe like, yes, you can use explanation as a cue to like convince the user further. The problem with confidence actually is that oftentimes, depending on like the type of query it is, or like how in domain the like test instances, there's no guarantee that your confidence is still going to be calibrated.
Yeah.
So even if a model was perfectly calibrated on offline data and it has like 100% confidence on this new like test instance, when I say I mean I, as someone who has like worked with models and like worked with model confidence estimates and like seen how brittle they are, I wouldn't like confidently say that like, oh, like even here it's going to be like perfect, like calibrated at the exact same level that I saw in my offline data. So if I'm saying it's 100% confident, I know it's 100% confident. If you can have some like guarantees about that, then yes, I do think that would be like an interesting thing to do, where like you provide explanations based on your own confidence. But yeah, I think the confidence scores are also often very critical. Yes.
I'm not sure if you mentioned this, but when you're bucketing users into confident versus not confident, are you only using their reported score at the beginning, or are you like updating that when they update their scores? Like,
What do you
on
mean
track?
confident and not confident?
So like you have, or I guess like high trust and low trust, like you're showing the users like counter examples or counter explanations versus explanations based on their trust scores.
Yeah.
Is that just the first trust score, or are you like
No, the trust score is reported
each,
at the end of every single
and you're updating
question,
their
and we're
bucket each
updating every
time?
single time. Yeah.
I was thinking it would be easy to model like trustworthiness, like,
Yeah.
because like it's either they accept the answer or, in the ChatGPT setting, are they copying the answer or are they liking it? There's a lot of these behavioral cues that people do to tell you that they like the answer, or like they'll regenerate the question if not. So I'm wondering like if it's like possible with those kinds of signals that you can definitely model whether you can trust or not.
I think like you can model whether like a person accepted an answer or not, but what's less easy to model is the like downstream outcome of accepting or not accepting. Like, did the user make a right decision? Did they get like some feedback from their environment that, oh, like this was the right diagnosis, or this was like the right answer that you like the final answer you went with was the correct one or not? And the effect that that feedback has on the user. So that is what trust is trying to capture. It's not trying to capture whether the user accepted the AI answer or like likes the AI answer or not. It's more, what are the downstream outcomes from like accepting or not accepting the AI advice, and what effect does this do these outcomes have on the user, and how they're likely to interact with the AI system in the future.
Okay, like future interactions.
Yeah.
Capturing. Okay.
I know you've worked mostly with, I think, tasks that have more or less a clear standard for what's accurate and what's not accurate.
Yeah.
What are is there any work that sort of tries to expand this framework or analysis into something that's a lot more decisions, but not necessarily as easily verifiable as yes or no, like creative tasks, like with writing, there's no one way to write one way or another, something like that.
Yeah, so subjective tasks or tasks where there's like no single correct answer.
Yeah.
There could be like multiple right answers, or like you could maybe like not even get feedback about like whether the answer is correct or not, even if a ground truth exists, but you don't have like access to it.
Yeah.
But then you have like your own internal cues that may update your mental model of the AI's ability. Those kind of tasks they're like much more interesting because they're much more abundant. I feel like most tasks that people interact with, or like that people try to do, have like no clear right answer. But it's very hard to operationalize those into actual studies.
I bet.
Yeah. So even in like HCI, I've seen like work that has looked at like writing, for example, like creative writing. And there you don't try to see maybe like if it like wrote the right thing or not, but maybe did it like increase the diversity of your generations, or like did it help you think outside the box? Those kind of things. And those kind of things also like have an impact on trust. And there's even like Ryan said, like trust itself is like not necessarily a very fine-grained concept. There could be like different axes to it, and some of these dimensions may impact like some aspects of trust versus others. So there is like more interesting things to study there, but
Gotcha.
outside the scope of this work.
Thanks.
All right.
Thank you.